Okay, now we're going to start our final review. Get 2 pieces of paper. That GCF stuff's not on the final because that test, that 5 problem test I gave, that's only part of the whole unit. Okay, and we're never going to get through that unit by the time semester's over. So these are the things you have to focus on your final. Okay. Okay, be on this one. And let's start. We've done these before. The original price of an item is $60. It's marked 30% off. Find the new price. Now, with these words being circled, they indicate add or subtract from what the price used to be before, okay? Or whatever the amount was before. So, off means minus. We put a little minus sign. Now, anytime we do percents in these words, that means add or subtract with the percent. You want to set up these 3 spaces. Blank times blank equals blank. Okay. And we have new, or sorry, my bad. Original, percent, and new. Okay. Original, percent, new. Now fill out the percent first. You take 100%. Because that's what this represents. The original is 100%. 30% off would be minus 30%. 100 minus 30 is 70%. Now that must be divided by 100 to put it in an equation. So 70 divided by 100 is 0.7. Okay, now the amount in the problem, just circle this, just look at the sentence. Just the sentence was $60. It clearly says that 60 is the original, okay? So $60 goes here, and X is the new. So to find X, it's very easy. X has no operations with it, so I'm just going to multiply these 2 factors together. 60 times 0.7, that's 42. 42 will have the same label as this. Okay, it's 1 unit, $42. Okay, number 2, an item is marked 30% off. Its new price is $1,400. Find the original price. So again, that word off, that means minus. Okay, so again, with these percents that are added or subtracted to the amount, okay, we always use this setup. This will get the job done. Okay, and we always put original, percent, and new. Okay, so my percent I take care of first. And again, it's off by 30%. It's going to be the same thing as what happened up here. Minus 30% is 70% divided by 100. And 70 divided by 100 is 0.7. Okay, now look at the sentence with 1,400, okay? It says its new price is 1,400. All you got to do is read. So that would be my new price, $1,400. And it says find the original. So X is the original. Now I can't multiply here because that's X. So what I do instead is divide. But you got to divide in the right way. Just extend that line. Put 0.7 below it, and those are gone. Then we'll have to divide the other side by 0.7. Just put that under the line. So now we have X equals 1,400 divided by 0.7 is 2,000. Okay, so just put 2,000 up there. And $2,000 is the original price. And then it was marked off. It ends up here. Okay, problem number 3. An item originally cost $50. It's marked 20% up. Find the new price. Now, up would indicate that it's added to the original price. Times blank equals blank. We have original, the rate, and then the new. Okay, so with the percent, we need to take 100% and add 20%. 100 plus 20 is 120, and then again that has to be divided by 100. It's 1.2. Okay, now I need to know where to put this. All you got to do is read the sentence. An item originally cost $50, so it's the original. And then I don't know the new. It says find the new price, so that's X. Whatever you have to find, that's where your X goes. And this is easy. X is by itself. You just multiply. 50 times 1.2 is 60. So 60, if that's dollars, 60 is going to be dollars. Okay, number 4. An item is marked up 25%. The new price is $200. Find the original price. Okay, so we have the original, the percent, and the new. And also up means add. So I take 100%, that's 100% of the original value, and add 25% of that original value, and that's 125%. Now I divide it by 100. That's 1.25 as a decimal. You're making the percent into a decimal by dividing by 100. Okay, what's it say about, what's the sentence? Just look at the sentence with $200. Just sentence stops. The new price is $200. Well, clearly it says that's a new price, so 200 goes here. Now I have to find the original myself, so that's X. So here's your multiplication, but you have X there, so you need to divide, okay? So divide by 1.25, and those cancel. Just put a, and then divide the other side by 1.25. So I take 200, divide by 1.25, and I get 160. And since that's dollars, $160. Okay, and that is how you do solve percent problems where a percent is being added or subtracted. Those words tell you what it is. Okay. Now on the back side. These are different. 20% of the students at school have eaten at Lawa's. 50 students have eaten at Lawa's. How many students are in the school? Now, these are not adding and subtracting like the back page was, okay? So you're not going to use the same method. What you're going to use is proportions. That's when you have two fractions on each side of the equation. You use 100% on all of these in the denominator. And then we put our percent in the numerator, okay? That easy. Now, what this problem is, it's a part whole problem. If you want to put P and W, that's fine. Part whole. You have to define the part by what I've underlined. It says have eaten at Lawa's. Now, sometimes the value in the problem goes here, sometimes it goes here. You have to read the sentence. Does it say they ate at Lawa's? Clearly it does. So 50 goes here and X goes here. And then I can just cross multiply and divide. I just multiply 100 times 50. Divide that by 20. I got 250. Now if you're wondering about the label, it's 50 students, so it'll be 250 students. Okay, number 6. 40% of the people in town voted in the election. 2,000 people live in town. How many voted in the election? So again, there's no word that indicates adding or subtracting. Okay, so it's a part whole problem. It's not the original percent new. That's 100%, and we have 40%. I'm really going to emphasize this because I think that's important to learn. This percents happen in real life all the time. That's 40% of the whole, okay? So it's part whole. Now you got to define your part. Part's defined by those that voted in the election. says there's a special characteristic that defines the part. I've underlined it to help you out. Okay, now read the sentence with the 2,000. Just a sentence. Does it say 2,000 people voted in the election? Clearly it doesn't, so 2,000 cannot go here. It has to go here. That's my whole, and I need to find the part that voted. So here's X, so I cross multiply the other way and divide by 100. 40 multiplied by 2,000 divided by 100 is 800. Okay, now the label on that, 2,000 people, so it'd be 800 people that voted in this election. It's like if you got 800 out of 2,000 points on a test, you'd have 40%. Okay, number 7, 90% of the students in a class graduated. 90 students graduated. How many students were in the class? Okay, so again, no word that nothing really indicates adding or subtracting onto like that, like the back of this did. So again, that's the part whole. So you put 90% and you always put it over 100%. And the 90% is your part, the 100% is your whole. The part is always defined by a certain characteristic. Well, here it's just those that graduated. So I'm given the value of 90. It says 90 graduated. Does say that trait, so 90 can go here, and I'm left to find the whole myself. So I cross multiply and divide. I take 100 times 90 divided by 90, and I get 100. Hey, they kind of match, okay? 90 students, so 100 students is the answer. Okay, number 8. I spend 40% of my money each month on house payments. I make $4,000 in a month. How much money spent on house payments? So again, okay, that's 100% is the whole, 40% is the part. Okay, so what defines a part? Well, house payments. So let's go analyze the $4,000. Is that spent on house payments? Does it say anything in that sentence about house payments? Nope, so I cannot put 4,000 here. That would be my whole. Then I need to find the part that's spent on the house payments. So I cross multiply and divide. 40 times 4,000 divided by 100. I got 1,600, and that's dollars. $6,000 spent on your house payments. Okay, now in our other packet, you have to take these numbers that have a lot of digits and simplify them by writing it in scientific notation. Okay? One thing, when you write a number in scientific notation, it's always something times 10, and then 10 has a power. All these answers look like that. Now, there's a certain way I told you to go about doing this. Find your decimal. It's right here, okay? Now, draw an arrow above the first number looking this way. It's got to be going left to right. That's not a 0. 0, 0, 0, 0, 0, 3. I'm going to highlight that with an arrow. Now, I need the decimal to move so it's between the 3 and the number after it. Okay, so the decimal needs to go here. I have to move this way, and that way is right. Okay, that's right. So if you're moving right, our exponent's going to be negative. Okay, it's like the opposite of a number line. So now move the decimal where you behind that number, between this number and the number right after it. 1, 2, 3, 4, 5. So now the decimal's here, 3.02 times 10. Now the power is negative, okay? Now to find what the negative power is, all you do is count the digits between the decimals. So 1, 2, 3, 4, 5. 3.02 times 10 to the negative fifth power. If you can always check your answer if you just go 3.02 times 10, the power keys here, and then negative 5. And you'll see that that's the same number you started with. Okay, now on my next problem, I don't have so it's something times 10, okay? 10 as a power then. Okay, I don't have a decimal to start with, so then it's automatically at the end. Now, looking this way, you need to find the first number that's not a 0, okay? Right there, that first number's not a 0. Here I had to go a ways till I found it. Here it's right at the beginning, so that's the number I highlight with the arrow. Now we need to move that decimal between the 4 and the number after it. It goes between the 4 and the 6. So that would be going this way, and that direction's left. Traveling left gives you a positive exponent. So now move it where it needs to be. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we have 4.6. You don't need all the zeros. If you have nothing but zeros after the number, you cut it off. Then count the digits between decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9, and it's positive. Okay? That tells you what the power is going to be. If you have to move the decimal this way, it's going to be negative. If you have to move it this way, it's going to be positive. It's like the opposite of a number line. Okay, blank times 10. Okay, I need a decimal to begin with. If I do not see it, it's automatically at the end. Now looking this way, highlight the very first digit that's not 0. Going this way. Not 8. That you're not looking this way. When you're looking for the number to highlight, it goes this way. Right away I have a 5. So that decimal needs to go between the 5 and the 8. Need to be moved. So to move it, which way do you go? You're going to the left, okay? Which means your power is going to be positive. Okay, now move it between these two. 1, 2, 3, 4. So I have 5.8 times 10. Now I count the digits between the decimals. 1, 2, 3, 4. And it's positive 4. So just put 4. You can punch it into your calculator. You should end up with 58,000. Okay, my next problem. I already have my decimal. I don't need to put one at the end because I already have one. Okay, looking left to right, that isn't going to work. That's 0. That's 0, 0, 0, 0. Okay, 7's the first number it can go, between the 7 and 4. So it has to move this way. So we're going to move it that direction, which is right. And a right is negative. Okay? So 1, 2, 3, 4, 5. And we have a 0.7 in front of the decimal and then 42 behind it. Now count the digits between the two decimals. 1, 2, 3, 4, 5, and it's negative 5. Okay, next one. Decimals here. That's 0. That doesn't work. 0, 0, 0, 3. Decimal has to go between 3 and 2, which means it has to go this way. And that direction is right. You got to know your right from your left. It's kind of right's negative in scientific notation. So I move it 1, 2, 3, 4 between these two. So we have 3.2. Then I count the digits between the decimal. It's going to be a negative. 1, 2, 3, 4. So 3.2 times 10 to the power of negative 4. Okay, next problem. I don't have a decimal, so where do I put it to start with? At the end. Okay, here's my first digit. That'll work. So it's going to go between the 7 and the 0. That would be going this way, which is left, meaning our power will be positive. So now move it between the 7 and the 0. The number you mark and the number after it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm not going to put the decimal. There's a 7 before it, but after the decimal is nothing but zeros. So I'm not going to put the decimal down here in my answer. Okay? Now you know your power's positive because of that. You move to the left, it's going to be positive. Now count the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of 9. Okay, next problem. Blank times 10. Decimals here. So find the first non-zero. That's 0. Not going to work. 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 7 will work. So to get between 7 and 4, the decimal has to go that way to the right, which will make our exponent negative. I'm going to put a negative right there. Okay, so move it. 1, 2, 3, 4, 5, 6. So before the decimal, we have 7.42. 10 to the negative power of 1, 2, 3, 4, 5, 6 to the power of negative 6. Okay, next one. Blank times 10. Okay, so I don't see a decimal. It means it's at the end. I look from the beginning. Okay, that's not a 0, so the decimal goes between that number and the number after. It's got to go right here. So that means I'm moving it to the left. That way is left, meaning we will have a positive exponent. So I don't put a negative there. It's positive. If I want to put a positive, fine, do it. So move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have point, we got a 5, we got a 6, don't need the extra zeros. And then the positive exponent, and then count the digits between the two decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power of positive 9. Now this time they give you a scientific notation number. You just have to write the number in standard form. You just use your calculator. 2.3 times 10 to the power of negative 5. I get 0 point, and then there are 4 zeros, followed by 23. It's like I'm going backwards from what I did on the first page. 3.46 times 10 to the power of 8. Okay, now I don't have a decimal, that's fine. Then if I don't see a decimal like I did here, I'm going to insert commas between every 3 digits. So comma, comma, that number is actually 346 million. Okay, next problem, 4.03 times 10 to the negative 7th power. Okay, we have a decimal, so I'm not going to write commas. 0 point. We have 6 zeros, and then 403. Okay, this one here, 5.21 times 10 to the power of 4. 52,001. Now I don't have decimals, so I need to put commas because the decimal's actually here. Don't write it, okay? And then the comma before the decimal, comma takes place between every 3 digits. So 52,100. Okay, now I'm going to do these along with you. Now you're back to scientific notation. So blank times 10. Decimal can't be here. That's a 0. 0, 0, 0, 0, 4. Okay, so it's got to go between 4 and 5. So I got to move the decimal this way. That is right. When we move a decimal to the right, then the exponent's negative. Okay. 1, 2, 3, 4, 5. So I'd have point and then 4, 5. Exponent's negative, then 1, 2, 3, 4, 5. 4.5 times 10 to the power of negative 5. Okay, blank times 10. Okay, you need the decimal. If you don't see it, you automatically place it at the end. And then look from this way. The very first number is not 0, so it can go between 7 and 4. It would need to move this way. That is left, meaning our exponent is going to be positive. Okay, so move it between this and this. 7, 2, 3, 4, 5, 6, 7, 8, 9. So there's my new decimal. 7 in front of it, 4 behind it. Now count the digits between the decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of positive 9. Again, right negative, left positive. It's like the opposite of a number line. Because normally on a number line you go right positive, left negative. This is opposite. Okay. Blank times 10. Decimal, don't have it. And the very first numbers are not 0 numbers, so we can put it between 5 and 0. That means the decimal travels this way, which is towards my left, meaning the exponent's positive. So 1, 2, 3, 4, 5, 6. So you got 5, 10, 1, 2, 3, 4, 5, 6. That's positive 6. Okay, then my last problem, blank times 10. Decimals here, but it can't, that's a 0. 0, 0, 0, 0, 3. So it goes between 3 and 7. It's got to be placed right here, meaning it moves this way to the right. Right means negative exponents. Okay. So 1, 2, 3, 4, 5. So we have 3.75, and then 10. 1, 2, 3, 4, 5. 10 to the power of negative 5. Okay, write it in standard notation. So 4.21 times 10 to the negative 7th power. A lot of zeros there. 0.123456421. Okay, then 6.32 times 10 to the 8th power. I don't see a decimal, so I'm just going to put commas every 3 places. Place values. 632 million. These are the ones, tens, hundreds, and then the thousands, 10,000s, 100,000s, million, 10 million, 600 million. Okay, so that's what we covered. That's kind of half your final scientific notation and those percent problems with the add subtract on the percent, and when I don't add or subtract the percent, it's just a part whole.